Okay, so let us solve. Let us find the that resultant that is kernel for the given this kernel this x e to the power of t. So okay, find the resultant kernel. So right kernel. So using Fredholm determinants, find the resultant kernel. Resultant kernel. It is not. Find the resultant kernel. So for given k of x comma t equal to x e to the power of t, a equal to 0, b equal to 1. Now we have that we know that b naught x comma t equal to k of x comma t, and which is given here, that's x e to the power of t. Okay. So next we find out the next question b1 x comma t equal to integral 0 to 1. Okay. So x e to the power of t, this is k of x comma t, and x e to the power of t1 means k of x comma t1. So this is t1 e to the power of t means k of t1 comma t, and t1 e to the power of t1 means k of t1 comma t1. And we integrate this with respect to t1, and the value of the integral is 0. So next we find the quotient b2 x comma t. So that is we integrate 2 times 0 to 1 and 0 to 1, and we have the determinant like k that is k x comma t and k x comma t1 and k x comma t2 and k t1 comma t, k t1 comma t1, k t1 comma t2. The other one is and k t2 comma t and k t2 comma t1 and k t2 comma t2. So we have the determinant and we integrate this with respect to that is t1 and t2, that is dt1 and dt2. So if we integrate this, we get the value as 0. So, and from this, we have the conclusion that the Bn will be 0 for all n is greater than or equal to 2. Okay. So once if it is 0, then next subsequent quotients are 0. So, and we find out the other the quotient, the Cn. So here is C1 is written as integral 0 to 1 and k t1 comma t1 dt1. So which is equal to, so k t1 comma t1 means what? We have this k x comma t is x e to the power of t. So therefore here is t1 and t1 we get, that is t1 e to the power of t1 dt1, and the integral value of this is equal to 1. Similarly, we go for this quotient C2. So that is given as integral 0 to 1, integral 0 to 1, and the determinant is k t1 comma t1, k t1 comma t2. Next k t2 comma t1, k t2 comma t2. So we integrate this with respect to t1 and t2. The value of the integral is 0. So from this we can conclude that so Cn values will be 0 for all n is greater than or equal to 2. This implies that if once a quotient, for example, Bn or Cn vanishes, then its all subsequent quotients will be 0. Now our job is to find the resultant kernel. So to find the resultant kernel, this R of x comma t comma lambda, so we need d of x comma t comma lambda and d lambda. So then d of x comma t comma lambda, we have the formula. So in the formula, we put the values of that is Bn, as well also in the values of d lambda, we submit the values of C1 or C2 and so on. So with that, d of x comma t comma lambda will be equal to just k of x comma t comma lambda, and other terms will be 0 in the summation. Therefore, the k of x comma t comma lambda is given here, which is nothing but this much. And d of lambda so will be the value as 1 minus lambda we get, because we have that is C1 is just 1 and other terms will be the zeros. So therefore, we left with 1 minus lambda. Now submit to these two things here. We have that is our resultant kernel as d of x comma t comma lambda will divided by d lambda is equal to x e to the power of t divided by 1 minus lambda. So here, if you see the resultant kernel, so this function is valid when lambda is not equal to 1, not equal to 1. Okay. For other values, then not equal to 1, then only it is valid. Otherwise, at lambda equal to 1, what happens? This resultant kernel is have the singular point. Okay. Okay. Thank you.